Good morning, everyone. A very good morning to all of you, bacho. We are live. We are back on ExamDost. We are back with the ESE Officer Practice Series for Engineering Services PYQ, Basic Electronics and Analog Electronics Part 2. Chali. So let us start the questions. ESE 2008. Peak current through the resistor. So, beta, for peak current, take the peak voltage 12 volt. Diode is ideal, so it will be short circuit. So it will be 8 milliampere. Okay. Next, in the circuit shown below, the Zener diode has a reverse breakdown of 400 and reverse saturation current of 20. The corresponding voltage for D2 are 50 and 50 microampere. What is the current in the device? So, beta, basically, this diode is forward bias. This diode is reverse biased. This is ESE 2008 based on supply voltage. Okay. This is reverse bias. Now, it is not in breakdown. Why? Because supply voltage is less than breakdown voltage. Supply voltage 40 और इसका breakdown है 50. So, beta, this diode will carry a reverse saturation current 50 microampere. So, answer will be D. Okay. The diode that is reverse biased will decide the current. And based on this current, you can apply diode current equation and find the voltage of diode 1. Then voltage across 2 is 40 minus V1, like this. In case of amplifier, which coupling gives the highest gain? Amplifier में कौन सी coupling ले highest gain के लिए? Transformer coupling. In transformer coupling, what happens? At resonance frequency, gain becomes maximum. ठीक है? The cut-in voltage of Zener diode D1 and D is 0.7. Breakdown voltage of Zener diode is 3.3. Reverse breakdown of D is 50. Other parameters are same as ideal diode. Peak output voltage V0. So for peak output, Vin is peak. That is 10. Okay. So assume it to be open. As of now, assume it to be open. Okay. Now, this branch basically needs how much voltage? This is the breakdown. This is the forward. 4 volt. Now, assume it to be open. What is V0? 10 into 1 by 1 plus 1, 5 volt. So, V0 equal to 5 volt is greater than 4 volt, which is required for branch to conduct. 4 वोल्ट पे डायोड वाली ब्रांच कंडक्ट करने लगती है, उससे ज्यादा मिल रहा है V0, therefore diode branch conducts and V0 becomes 4. So positive half cycle is 4. Now for negative half cycle, Now this requires 0.7, similar to a diode, and this requires 50. Therefore, branch requires minus 50.7 volt to conduct. Now assume branch to be open, V in to be minus 10 volt, negative peak, so it is minus 5. Now this is not sufficient for diode branch to conduct. In negative half cycle, the diode branch requires 50.7 volt. Therefore, diode branch will remain open and V0 will be minus 5. So answer will be B. लॉजिक समझ में आया? क्योंकि ये रेगुलर वाला जो डायोड है इसका ब्रेकडाउन वोल्टेज बेटा -50 है, तो इसको 50 वोल्ट चाहिए रिवर्स रीजन में। इसे कंडक्ट करने के लिए रिवर्स बायसिंग में 50 वोल्ट चाहिए, उतना मिल नहीं पा रहा, तो ये भाई साहब ब्रेकडाउन में नहीं जाएंगे। फॉरवर्ड साइकिल में जीनर डायोड ब्रेकडाउन में चला जाएगा, लेकिन रिवर्स साइकिल में दूसरा डायोड ब्रेकडाउन में नहीं जाएगा। ESE 2009. Consider the following statement with respect to a tunnel diode. Tunneling takes place at a speed decided by junction temperature. No. Concentration of impurity. It is highly doped. Tunnel diode is highly doped. Both tunneling and normal PN junction current exist. Yes. Current control negative resistance characteristic only. No. कैरेक्टरिस्टिक में सिर्फ नेगेटिव रेजिस्टेंस नहीं, पॉजिटिव रेजिस्टेंस भी आता है ऐसे। दिस इज नॉर्मल डायोड। तो नॉर्मल डायोड में देयर इज अ पॉजिटिव रेजिस्टेंस, so this statement is correct. Incorrect. Forward resistance of diode is 5 ohm, DC component of the source current. DC is I average. This is a half wave rectifier. So Vm by 50 pi. A. Vm by 50 pi, because this is 5 ohm, load resistance 45, this is ESE 2009 50 ohm. The 6 volt ESE 2009, again Zener diode has zero resistance, knee current of 5 milliampere. So what is the current from here? 4 by 50, 80 milliampere. So current in the load resistance 75 milliampere maximum. Okay. So if load current is greater than 75 milliampere, basically Zener current goes below 5 milliampere and comes out of breakdown region. Therefore, IL max is 75 milliampere. For maximum IL, resistance is minimum 6000 by 75, 80 ohm. So minimum value is 80 ohm. ठीक है, जब लोड का करंट मैक्सिमम है माने रेजिस्टेंस मिनिमम है। वेरी गुड बेटा, आनी तो चाहिए ईएससी में रेलवे की वैकेंसी। फॉर अ साइनोसोइडल इनपुट पीक VP, output voltage V0 will be. So this is basically beta shunt positive clipper clips V in greater than minus VR. Okay, this is minus VR. So answer should be D. माइनस वी आर से ऊपर का क्लिप कर देगा फॉर वी इन लेस देन माइनस वी आर. बेसिकली वी इन लेस देन माइनस वी आर. डायोड इज ऑफ. वी नॉट इज वी इन. वी इन ग्रेटर देन माइनस वी आर. डायोड इज ऑन. वी नॉट इज माइनस वी आर. तो माइनस वी आर से ऊपर वाले पोर्शन के लिए माइनस वी आर ही देगा. ESE 2010. In a full wave rectifier, it is necessary to use identical diode having identical characteristic. तो ये कह रहा है फुल वेव रेक्टिफायर में जरूरी है कि आइडेंटिकल कैरेक्टरिस्टिक मिले. ऐसा जरूरी नहीं है. बिकॉज प्रैक्टिकली यू कैन नेवर हैव टू डायोड्स विच आर एब्सोल्युटली आइडेंटिकल. आप कैसे भी मैन्युफैक्चर कर लो बेटा, कोई भी दो डिवाइस कभी भी आइडेंटिकल नहीं हो सकती. दे कैन नेवर बी लाइक दैट. ESE 2010. In the work function model of Schottky barrier diode contact to N-type semiconductor, the metal work function will be higher than semiconductor. Yes, metal work function is higher than semiconductor. To equalize the Fermi level on both sides, electron from semiconductor move to the metal side, forming a space charge region at semiconductor. Correct. इलेक्ट्रॉन जो है ना एन साइड से मेटल में मूव करेंगे. दैट इज लोअर टू हायर पोटेंशियल. देयरफॉर मेटल हैज हायर वर्क फंक्शन. ESE 2011. Dark current in a semiconductor photodiode is reverse saturation current. Okay, because photodiode is operated under reverse bias. So when you do not incident any light, it basically carries reverse saturation current. Consider the following statement. A Zener I think now you will be able to see me and hear me. So beta, in a diode, due to capacitance at high frequency, the shape of the signal will change. Zener voltage does not vary with temperature. No, it has a negative temperature coefficient. Regulation is adversely affected at knee current due to limited power dissipation. Power dissipation is related to IZ max, not IZ min. Amplification is not possible. Yes, because there is no active device. For amplification, we need a active device. So 1 and 4. ESE 2012. In open circuited PN diode, the space charge density at the junction is 0. It exists on both sides of junction, not at junction. जंक्शन के दोनों तरफ एग्जिस्ट करता है. मटेरियल यूज फॉर फैब्रिकेशन ऑफ टनल डायोड, जर्मेनियम और गैलियम आर्सेनाइड, नॉट सिलिकॉन. 6 volt Zener diode repeated. This is ESE 2013. This is a repeat question. A full wave rectifier using center tap transformer and a bridge rectifier using similar diode having equal voltage under equal load condition. अगर equal load condition होगा, output of bridge will be less than other because two diodes conduct at same time. Therefore, drop equal to 2IRD. So bridge rectifier has more drop. Okay, bridge rectifier has more drop as compared to your full wave rectifier. क्योंकि देखो नो लोड आउटपुट तो सेम है, दिस इज सेम. तो लोडेड कंडीशन में क्या होगा? लोडेड कंडीशन में here two diodes are conducting at a time, so the drop will be higher. ESE 2014, for a forward bias diode, diffusion capacitance will dominate transition capacitance because transition capacitance dominates under reverse bias. ठीक है, ट्रांजिशन या जंक्शन कैपेसिटेंस रिवर्स बायस पे काम करती है. फॉर अ पीएन जंक्शन अंडर रिवर्स बायस, द मैग्नीट्यूड ऑफ इलेक्ट्रिक फील्ड इज मैक्सिमम एट द सेंटर ऑफ डिप्लीशन रीजन. सॉरी, पीएन जंक्शन, ये भी एक ऑप्शन है ना, यहां पे ना इसको साइड भी देनी चाहिए थी. तो देखिए, this is how my electric field basically varies. Like this. So maximum at junction. Okay. As compared to a LED, LCD has a distinct advantage of low power consumption. LCD का power consumption LED से काफी कम होता है. The increase in value of beta of a transistor can cause the fixed bias circuit to shift from active to saturation. Because as beta increases, IC increases, VC decreases. So we move towards saturation. Basically, if you see the load line, this is the load line. This is 0.2. So this is saturation region. तो IC बढ़ना और VC का घटना, that is moving towards saturation from active. है ना, we are moving up and the left. So we are moving towards saturation. ESE 2015, PN junction under reverse bias, magnitude of electric field is maximum at under reverse bias, again at PN junction. Electric field PN junction पे ही maximum होगी. A silicon diode is preferred to germanium because it has lower reverse current and higher breakdown voltage. Reverse saturation current of silicon is less than germanium. Compared to ordinary diode, a Schottky diode has lower cut-in voltage and higher reverse saturation current. Why lower cut-in voltage? Because of absence of depletion layer on P side. P side is now replaced by metal. So there is no depletion layer inside metal. So cut-in voltage decreases. ठीक है? Hot carrier diode. Hot carrier diode is the Schottky diode. Hot carrier means more energy. Charge carriers have higher energy or they move at higher speed. Ripple rejection ratio of a voltage regulator is the ratio of input ripple to output ripple. This should be greater than 1. Okay. इनपुट का रिपल आउटपुट के रिपल से ज्यादा होना चाहिए. ये कह दो आउटपुट में रिपल कम जाना चाहिए. आउटपुट रिपल शुड बी लेस. Schottky diode is a majority carrier device because there is no PN junction. तो जहां भी PN junction involve होगा, that is a minority carrier device. Okay. Wherever PN junction is involved, it is a minority carrier device. ESE 2015 in a L section filter, bleeder resistance is connected across the load. Why do you connect the bleeder resistor? It provides good regulation. In capacitive filter, it will allow discharge of capacitor. But in inductive filter, bleeder resistor provides better regulation. A power supply uses bridge rectifier with a capacitor input filter. If one of the diodes is defective, in bridge rectifier, if one of the diode is defective, it acts as half wave rectifier. Okay. It acts as half wave rectifier. So DC voltage will be less. It will become Vm by pi. F0 will become F. In bridge rectifier, F0 is 2F. So ripple frequency decreases. Surge current will increase considerably. Surge current is the peak diode current. So it is more in half wave rectifier as compared to full wave. Okay. So answer is all of them. देखो क्या होता है ना, when you have a capacitive filter, then when your capacitor charges, that time current flows through the diode. So the peak current is lesser in case of full wave rectifier as compared to half wave, because in full wave rectifier capacitor charges for a smaller duration. फुल वेव में कैपेसिटर कम ड्यूरेशन के लिए चार्ज होता है. रैंक इंप्रूवमेंट बैच के बारे में बेटा जुलाई में स्टार्ट होगा वो. क्लैंपर सर्किट ऐड और सब्ट्रैक्ट डीसी वेव फॉर्म एंड इट डज नॉट चेंज द शेप. सो बोथ आर करेक्ट. टोटल कैरेक्टरिस्टिक ऑफ अ स्टेबलाइजर इज कांस्टेंट आउटपुट विद लो रेजिस्टेंस. बेसिकली क्लोज to an ideal voltage source. एक आइडियल वोल्टेज सोर्स जैसा होगा. ESE 2018, the two type of current in semiconductor, diode and transistor is drift and diffusion. Junction is called depletion region or space charge region. When current flow through the diode, the current is mainly of diffusion type. Yes. Forward bias में जो current होता है, that is diffusion current. In reverse bias, it is drift current. ESE 2019, Shockley equation. D option. Okay. Sorry. B option. VD by eta VT minus 1. ESE 2019, in emergency lighting system, component used for maintaining the charge on the battery. Who will maintain charge on the battery? LED. In tunnel diode, ESE 2020, the width of junction barrier. This you have to remember. Depletion width is basically like this. Proportionality is like this. Inversely proportional to root of doping density. Ideal power supply output voltage is independent of load and regulation is 0. Regulation 0 माने no fluctuation in V0 with respect to load. In a PN junction diode, reverse saturation current increases by 7.2%. by a degree centigrade rise in temperature. For 1 degree centigrade, it increases by 7.2% and it doubles for every 10 degrees centigrade. It will double for every 10 degrees centigrade. Boltzmann diode equation. See, Shockley and Boltzmann diode equation is या सेम ही तो लिखा है ए और सी. ESE 23. A silicon diode made half wave rectifier has a maximum current 20 milliampere, resistance 1 kilo ohm. PIV. PIV will be 20 volt. In half wave rectifier, V in will be V naught plus VD. .7 peak. Now PIV is peak of the input voltage 20.7. Okay, this is my diode voltage. Okay. Ripple factor for half wave and full wave 1.21 and 0.48. This is directly you have to remember half wave and full wave. Okay. Next, ESE 23 diodes designed specifically to operate in forward bias region are Zener diode. Zener diode are designed to operate in reverse bias. Principal region is negative voltage, negative current, that is third quadrant. है ना? Zener diode की कैरेक्टरिस्टिक थर्ड क्वाड्रेंट की होती है. पीक और मैक्सिमम वैल्यू एक ही लेते हैं यार, यहां तो एनालॉग के अंदर तो ऐसा कोई डिफरेंस नहीं है. ESE 24 nominal value of potential drop across silicon, Schottky and LED. Okay, silicon diode, Schottky diode and the LED. So answer should be A. Schottky diode का बहुत कम होता है, LED का 1 वोल्ट के आसपास आता है. ESE 24 in the non-conducting region, diode current is exactly 0. Approximately 0. Basically, diode current is equal to reverse saturation current. So this is wrong. Yes, this small voltage is called Neev voltage. To turn on the diode, you need a small positive voltage called Neev voltage. Diode does not enter breakdown region in forward, only reverse bias. Breakdown only happens in reverse bias. ESE 24 again. What happens to the depletion region and depletion capacitance with increased reverse bias voltage? Depletion region widens and depletion capacitance. देखो depletion width तो बढ़ेगी and capacitance decreases by epsilon A by W. So when you increase the reverse bias, the voltage increases, width increases, capacitance decreases. चलिए, coming to the transistor now, ESE 2001. A circuit using BJT is shown. The value of beta is. So this current 8.3 by 5. This is basically IE. This is basically IE. Now how to calculate IB? You can say this is 1 by 100. This is coming from here. Okay. So IB is 1 by 100 milliampere. Now beta plus 1 is IE by IB. 166. Therefore beta is 165. See, 165. Okay. The Darlington ESE 2001 Darlington pair has a current gain of beta square, voltage gain AV, input resistance RI, output resistance R0. When it is used in the emitter follower configuration A, R and R0 R. Now in emitter follower, voltage gain is approximately equal to 1. एमीटर फॉलोअर की खासियत है वोल्टेज गेन 1 के आसपास होता है. इनपुट रेजिस्टेंस ऑफ डार्लिंगटन पेयर इज हाई एंड आउटपुट रेजिस्टेंस इज लो. तो बी डार्लिंगटन पेयर का इनपुट रेजिस्टेंस बहुत हाई होता है. ESE 2001 assume beta is 100 the region of transistor. So basically at AB VTH RTH देखो कट ऑफ तो जाएगा नहीं, इनवर्स एक्टिव भी नहीं जाएगा. So we just have to decide between saturation and active. So beta is 100. So IE, we will assume active region and we will assume 0.7 drop. So basically what will happen? IB into 20 by 3. So IB 20 by 3 plus 2 not 2. So IC. Okay, now we need VCE. 10 minus 8 IC. This is negative, so it is saturation. Because VCE is less than 0.2. मैंने वही बोला ना VCE निकालना पड़ेगा. ठीक है, so it will be in saturation region. ESE 2001 for the circuit shown in the given figure, assume beta is 200 VB 0.7. IC value in the active region. So apply KVL. 10 IB plus 201 into 0.45 IB. So it will be 90, 100 IB, 0.5 by 100, 5 microampere. मैंने बेटा बस यहाँ पे अप्रोक्सीमेशन क्या किया, मैंने अप्रोक्सीमेशन बस यहाँ पे ये किया मेरे बच्चों, दैट 201 को मैंने 200 ले लिया. I consider 201 as 200. Capacitance. Because we are doing DC analysis, in DC capacitance will be open circuit. Okay. चलिए मेरे बच्चे, इतना आपको डिटेल में जाने की जरूरत नहीं है कि टॉर्च के अंदर क्या चीज बैटरी मेंटेन करेगी, कैसे चार्ज. ठीक है, ये ट्राई करो. चलो थैंक यू भाई, इफ यू आर फाइंडिंग इट हेल्पफुल. Most dominant speed limitation in a transistor is brought about by fall time. Okay, this is maximum among all timing parameters. So basically, fall time makes a transistor slow. Early effect in BJT refers to base narrowing. So what happens as reverse bias across collector base junction increases, okay, the base width decreases due to depletion. Darlington pair is mainly used for, why do you use Darlington pair? Impedance matching. Zn is high, Z0 is low. So basically it is used for impedance matching between a high and a low impedance. EMFT बेटा आपको परचेज करना पड़ेगा. EMFT is not available on YouTube. That is available as a separate course on our app. Silicon transistor as a common emitter amplifier, quiescent collector voltage. It is asking VC. So again beta VTH. RTH 10 parallel 5, 10 by 3. Twenty by 3, 10 by 3. This is 10K, 10K, 20. Now, what is beta? Beta is 100. So IB, 101 IB. This is 0.7. Apply KVL. So IB. 0.588 milliampere. V naught 20 minus 10 IC 5.88 14.12. See, answer is 14 volt. In a transistor circuit, the collector to ground voltage is 20 volt. So basically VCE is VCC, therefore IC is 0. So this is एमीटर टू ग्राउंड कनेक्शन ओपन. अगर एमीटर को अनग्राउंडेड रखोगे तो करंट फ्लो नहीं कर पाएगा. देयरफॉर IC विल बी 0 एंड VCE विल बी इक्वल टू VCC. कॉमन एमीटर एम्पलीफायर. यूज ऑफ नेगेटिव फीडबैक. Conversion of DC power to AC, high voltage and current gain, the use of a step-up transformer. High power gain is due to 2 and 3. Power gain इसलिए होता है जो DC biasing वाली पावर होती है ना बेटा. So the power gain is because the power from the DC supply gets converted to AC. And since the voltage and current gain product is equal to power gain. Amplifier का power gain आता ही बेटा इसलिए because your DC power gets converted to AC. V0 to V2 minus V1. V2 is basically 0. This is common emitter amplifier. So gain is minus RC by RE. But यहाँ पे V0 by V1 है. V2 minus V1. So this will be RC by RE. Gain ये पॉजिटिव आ जाएगा. ठीक है. Gain will be positive RC by RE. A silicon transistor with VBE sat 0.8 beta 100 VCE sat 0.2. Minimum RC for which transistor is in saturation. ESE 2004. Minimum RC for saturation. So what is IB? 5 minus 0.8 by 200. 2.1, 21 microampere. At edge of saturation, it is 2.1 milliampere. Okay. Now take VCE as 0.2. So RC 9.8 by 2.1, 4.66. So it is B. Next try करिए भाई. Try the next one. चलिए लेट अस सी दिस बेटा. Beta is 100. So IB is this 430 by 252, 1.706. Now VCE 10 minus 3 IC minus 2 IE. So this will be approximately 5 IC. This is greater than 0.2. So it is active region. C option. ठीक है. इसको भी IE को ना IC ले लो approximation के लिए. Take IC, IE also equal to IC. ICO. This is the relation between ICBO, ICO. ICBO is greater than ICO and it doubles for every 10 degrees centigrade rise in temperature. Dynamic characteristic of a transistor are represented by A1IB plus A2IB square due to square. A plus B square cos omega 1t cos omega 2t. Okay. I2 square by 2 cos A cos B cos A plus B cos A minus B. Two omega 1, 2 omega 2. ये जो है ना omega 1 minus omega 2 आएगा. DC because of this constant. Omega 1 and omega 2 because of this IB. ठीक है. ये IB वाले की वजह से ओमेगा 1 ओमेगा 2 आएगा और इसकी वजह से 2 ओमेगा 1 2 ओमेगा 2 ओमेगा 1 प्लस ओमेगा 2 ओमेगा 1 माइनस ओमेगा 2 और कांस्टेंट टर्म दैट इज DC. Emitter in a BJT is doped much more heavily than base as it increases the emitter efficiency, base transport factor and forward current gain. All of these will increase if emitter is highly doped. Beta, ICBO has one extra term which is called as surface current. इसीलिए ICBO का इस्तेमाल करते हैं. ICO और ICBO में इतना ही फर्क है. ICO is the reverse saturation current and ICBO contains the surface current also. ESE 2005 for common emitter configuration which statement is correct? It has large voltage gain and low output resistance. करंट गेन भी इसका वैसे लार्ज होता है तो ये भी सही है. इसका वोल्टेज और करंट गेन दोनों ही हाई होता है तो A एंड B. Next, match the column. Common emitter amplifier, high power gain. That is why it is used as amplifier. Emitter follower, common base amplifier, current gain is approximately 1. Darlington pair, very low output resistance. Emitter follower, beta multiplication नहीं, emitter इसमें आएगा. It will become beta square. Emitter follower, low output resistance. तो 4 1 2 3. ठीक है, बीटा स्क्वायर हो जाता ना. इट इज अ सुपर बीटा ट्रांजिस्टर. बीटा गेट्स मल्टीप्लाइड. ESE 2006. What is the thermal runaway? What is the thermal runaway? It is due to increase in the reverse saturation current. तो देखो क्या होता है. As temperature increases, ICBO increases, IC increases. So power dissipation VCE into IC increases. Again, temperature increases. In the circuit given below, if the output is taken from point E instead of node C, what will happen? अगर आप C की जगह E से आउटपुट लोगे, आउटपुट impedance reduces because it will become emitter follower. Emitter follower has low output impedance. ESE 2006, correct with respect to BJT. Avalanche multiplication start when VCB equals BVCBO. Early effect as soon as the punch through. Early effect start as soon as punch through occurs. नहीं. Okay. Small signal HFE is equal to large signal current gain when del HFE by del IC 0. In common emitter mode, a transistor can be cut off by reducing IB to 0. यार ये भी सही है, कॉमन एमिटर में IB को 0 करेंगे तो. और ये भी सही है, एवलांचे ब्रेकडाउन स्टार्ट्स व्हेन द वोल्टेज इक्वल्स. ये गलत है. स्मॉल सिग्नल करंट गेन और लार्ज करंट गेन इक्वल तो नहीं होंगे. एक बार देख लेते हैं यार, इसको ना चेक कर लेता हूं मैं. दो कैसे आ रहे हैं इसके. मुझे लगता है इसका दो ही होना चाहिए, ए और डी. अर्ली इफेक्ट का ना एक्सट्रीम केस होता है पंच थ्रू. व्हेन यू कीप ऑन इंक्रीजिंग द वोल्टेज, द अर्ली इफेक्ट डोमिनेट्स एंड यू गेट द पंच थ्रू. ओके, सो ए एंड डी शुड बी. If alpha R and alpha F and alpha R denote the forward and inverted mode current gain, which of the following is correct? So this is from the Ebers mole model, alpha F and alpha R. So alpha F is always higher because this is due to emitter current which is heavily doped. Alpha F जो होता है ना, emitter current की वजह से आता है, which is heavily doped. So this is higher. For the common emitter configuration shown, the current stabilization factor is given. What is the voltage stabilization factor? वोल्टेज स्टेबलाइजेशन फैक्टर करंट वाला दे रखा है. So it will be RE multiplied I naught, basically IE by IB. Current stabilization factor for RB much less than beta RE. तो इसका जो आ जाएगा, डायरेक्टली देखें तो यार देखो, डायरेक्टली तो निकाल सकते हैं इसका, डेल ICBO, ठीक है। दिस इज यही होता है ना। तो नाउ ये 1 माइनस होता है मेरे ख्याल, ये दे रखा है 1 प्लस RB बाय RE, वोल्टेज स्टेबलाइजेशन फैक्टर, वोल्टेज स्टेबलाइजेशन फैक्टर। वोल्टेज स्टेबलाइजेशन फैक्टर ये देखना पड़ेगा यार, वोल्टेज स्टेबलाइजेशन फैक्टर कितना आएगा। वोल्टेज स्टेबलाइजेशन फैक्टर होता है डेल्टा VCE बाय डेल्टा VBE, basically change in output voltage with respect to change in input voltage. Okay. नाउ सप्लाई वोल्टेज आ जाएगा, देखो VBB माइनस IBRB माइनस VBE माइनस IERE। ओके, ये आया। अब मान लो IC is approximately equal to IE which is equal to beta IB। ओके, beta RE plus RB, this is your IB। now what is VCE या V नॉट निकाल लो, VCC माइनस ICRL। बट अगर VCE ही निकाला जाए, क्योंकि V नॉट तो VCE के बराबर है ना, माइनस अप्रोक्सीमेटली इसको भी बीटा आई भी ले लो, बीटा RE प्लस RB RL प्लस RE। अब ये बोला है आर बी इज मच लेस देन बीटा आर ई. So del V naught by del VBE is what? Beta RE, approximately if we call 1 by beta. नहीं यार, अब और तो यार इसमें कुछ मुझे समझ नहीं आ रहा. वोल्टेज स्टेबलाइजेशन फैक्टर का और कुछ दे रखा है क्या कहीं पे? करंट स्टेबलाइजेशन फैक्टर, चलो इसको मैं एक बार चेक कर लूंगा यार, वोल्टेज स्टेबलाइजेशन फैक्टर को. ठीक है, ये मैं एक बार चेक कर लूंगा. अगला देखते हैं. मैक्सिमम जंक्शन टेम्परेचर इज 150, एम्बियंट टेम्परेचर इज 25, पावर डिसिपेशन डेल्टा टी बाय थीटा 150 minus 25 by 1, तो 125. ठीक है. ट्रांजिस्टर कॉम्बिनेशन shown in the figure below. Transistor combination shown in the figure below. बताइए. What is the transistor combination shown in the figure below? ये तो सबको दिख रहा है. Complementary pair, because this is PNP, this is NPN. So this is a complementary pair. Maximum power, ESE 2009. Maximum allowable temperature. What is the limit? So theta 0.5. So if we have ambient temperature 55, 240 B. Last question. Beta of a BJT varies from 15 to 65. RL is 10, VCC is 120, VBB is 8. VC is at, VB is at, RB. That will result in saturation with overdrive factor of 10. Overdrive factor means IB is 10 IBS or 10 IC by beta. Okay, 10 IC by beta. So VB 1.75. This is 1.25. VCC is 120. RL 10. $118.75. IB is what then? 118.75 by beta. This is IB. IB is basically 8 minus 1.75 by RB. So RB is what? 5.25 or 6.25. Now, it is asking what is the value of RB. Beta can vary from 15 to 65. So multiply by 15. 0.789, and if you take 65, 3.42. So minimum value is 0.79. ठीक है, मिनिमम वैल्यू इज 0.79. ये ठीक है. एक सेकेंड, बीटा 15 है, ये 10 ओम हुआ ना, 11.875. तो यही आना चाहिए यार इसका. तो बी, कैलकुलेशन तो ठीक ही दिख रही है. 11.875 10 IC बाय बीटा 118.75 बाय बीटा. ठीक है, 0.79 ही आएगा इसका. द आंसर विल बी 0.79. ओके, चलिए. So that's it बच्चों. Now I'll see you on Monday. Again we'll meet on Monday for more question on basic electronics. Thank you.